Hello everyone, our project is trying to implement the 2D DCT, which is a discrete cosine transform using VHDL. This is the top level block diagram of our design. It mainly has a DCTI as the 8-bit input and DCTO as the 12-bit output. We use two features to improve the efficiency of our logarithm. First, we use a distributed logarithm to store the transform matrix in the ROM. So in that case, we can avoid multiplication and accumulation during calculation. And also, we use two transform RAMs here. Since for 2D DCT, it will first perform 1D DCT to the column vectors, and then it will perform another 1D DCT to the row vectors. So it will have two stages here. When the first stage finishes its job, it will store the values in the first RAM, and the second stage will read the data from the first RAM and start working. And simultaneously, the first stage is still working, and it will store the values into the second RAM. With this pipeline design, we do not need to worry about the flow control anymore. So that's all for the block diagram. And we have a slightly different test bench from what we have learned in class. It is because the DCT coefficient we get from MATLAB has decimals, and the output of our project are only integers. So there would be errors anyway. So in that case, we choose to store the values we got into a TXT file, and then we use MATLAB to measure the performance of our design. So here's how it works. First, we read the fishing boat as a we read the fishing boat TXT as our input, and also we write the output of data to a test bench result file.txt. Okay, now it works. Let's do a project do. So after 27 milliseconds, it finishes its job, and we can see there is a test bench result.txt file here. Now let's first create simulation and copy the txt file we got into the MATLAB folder. This is the MATLAB code we use to measure our design, and this is the original fishing boat image we use. So now let's open MATLAB and drag the code here. You can see it first read the fishing boat image, and also it read the test bench result data we just got. So now let's do it. Okay, so we can first find here there is a recovered image using the DCT coefficient we got from VHDL file. And first we calculated the root mean square error between the DCT coefficient of our design and what we got from MATLAB. It is about 0.9, and also we compare the PSNR between the original image and the recovered image, and it is about 48 dB. So it mainly implies it is a good design, because if you see the image, you can barely see the difference between them. So here's about test bench. And when we are trying to demo on FPGA, we consider using UART to build the communication between FPGA and the PC. And for the receive part, it works fine, because you can see here we are trying to send one block of image data into our FPGA, and I press this one and I stop here. You can find that the last byte I transmit is 9D, and I use LED to show that this one is 9, this one is D. So the receive part is good. However, we're facing a challenge when we're trying to transmit the data from FPGA to PC. It is because in UART it can only contain 5 to 8 bits of data. so first we try, but the output of design is 12 bits. So in that case, we first try to divide the 12 bits into 2 bytes, which give us 2 redundant bits to show which one is the least, means the first one, or which one is the last one. And also we try to follow Alex's suggestion to put a multiplier at our output to determine which one to output. However, no matter how much time we spend on debugging, the output of the output received on PC still make no sense. So, and we are running out of time, so we consider it the remaining task, since the main purpose of this project is to try to implement 2D DCT using VHDL, and we think we have done most part of our project. And if we know UART better, or we have more time debugging, I think we can finish it in the future. So that's all for it. Thanks, guys.